Hello everyone. So let's see how to solve today's question. So the question is minimum number of seconds to make mountain height zero. Okay. So let's go through the question description once. So you are given an integer mountain height denoting the height of the mountain. So the mountain height is given in this mountain height variable. Then you are also given an integer array worker times representing the work time of worker in seconds. Okay. So there will be an array in which some values will be there, which will be denoting the time taken by each worker. Okay, the time taken by each worker. Okay, and the time is given for what? The time is given to cut the mountain. Okay, to cut the mountain. So the worker works simultaneously to reduce the height of the mountain. Okay, so they are basically cutting the mountain. So for worker I, if you take any ith value from this array, okay, then to decrease the mountain height by x. Okay, so if for any height of x you want to decrease of the whole mountain, how much time it will take for that worker is given as worker time I plus worker time times I into 2 plus dot 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 till worker times I times x. Okay, so what does it mean? Suppose if the time is given as, suppose for 0th worker or the first worker, if you take, so the time is given as 2. Okay, so suppose if you are cutting it down, uh, so this worker is cutting down for a height of 4. Okay, if it is cutting down for a height of 4, the time taken by this worker to cut down this height of 4 will be 2. Okay, this will be 2 plus 2 into 2 plus 2 into 3 plus 2 into 4. Okay, okay, so that's how the time will be taken. So this can also, we can just simplify, if we just take out, this 2 out of this, so this can be written as 2 into 1 plus 2 plus 3 plus 4. Okay, so this is nothing but the sum of x, so this is 2 into x times x plus 1 divided by 2. Okay, so that's how we can write it, like, okay, so once we have this information, so we have the information of how much time it takes for each worker to cut the height. So to reduce the height of the mountain by 1, this will take worker times I seconds. To reduce the height of the mountain by 2, it takes worker times I plus worker times I into 2 seconds, and so on. So as I told you, so this is just given that. Then return an integer representing the minimum number of seconds required for the workers to make the height of the mountain 0. So we need to cut down the whole mountain. Okay, so this whole mountain height should be 0 in the end. Okay, so we need to tell us in which what's the minimum time in which you can cut down the whole mountain. Okay, we can cut down this whole mountain. Okay, so let's go through one example also. So in this example, if you see, what's given is that the mountain height is 4. Okay, and worker times is 211. Okay, so in this they have chosen, like, this worker 0 will reduce the height by 1. Okay, so this worker 0 when reduce the height by 1, so how much time it will take? It will take just worker times 0 times. Okay, so this will just take 2 seconds only. Okay, then worker 1 is given the responsibility to cut, like, 2 unit of height, okay, of the mountain. Okay, so then how much time it will take is worker times 1 plus worker times 1 into 2. Okay, because it needs to cut down 2, so we will be going till 2. Okay, so the time is this will take is 3. Okay, because this will be 1 plus 1 to 2, this will give us 3. Okay, then worker 2 is given the responsibility to cut just 1 unit of height, so again this will take 1 unit of time, so this is 1 second. So now, keep in mind, they all of them are like cutting it down like simultaneously. Okay, the worker works simultaneously to reduce the height of the mountain, so all of them are working simultaneously. It's not like, first of all worker 1 will cut some part, then worker 2 will cut. Okay, no, it's not like that. Well, all of them are working simultaneously. Okay, so what will be the, like, what will be the thing by this is that, so suppose if they were cutting it down one by one, so the time taken would have been 2 plus 3 plus 1. Okay, so the total time would have been 5. But as they are cutting it down simultaneously, so worker 1 when this worker 1 will finish, these two would also have finished their heights. Like this would have reduced the height by 1, this would have reduced the height by 1, and this would have reduced the height by 2. So the whole height of the mountain would have been reduced. Okay, so we will take the maximum of these. So we will take the maximum of these values, like which one worker took the maximum time. So that will be our answer. Okay, why? Because they are working simultaneously. Okay, that's the thing. Okay, so like when you see this problem, so this is like a typical binary search like problem. Okay, why I'm saying is that, like whenever you see something like you have to find the minimum of maximum. Okay, or you have to find the maximum of minimum. Okay, so this is typically a binary search problem only. So that's why we can think in that direction. Okay, so if you have solved like previously some questions like this, you would have also thought it like that. So now how can we solve it? Like, okay, so we will do binary search on the answer. Okay, so binary search on answer how? Like what's the maximum time which we can take to cut the mountain? Okay, so what will be the maximum time is given by the worker which is taking the maximum time. Okay, so suppose if I just decide to make only this worker work. Okay, I say I will not make these two worker work. I will make the one which is taking the most time cut down the whole mountain. Okay, so that will be my maximum time. There is no way i I can take more time than that to cut the whole mountain. So the worker, if I give a single worker which is having the most unit of time to cut the mountain, so if I give the responsibility totally to him or her, so then it will cut the mountain. Okay, so like how much time will it take? So how much time will it take will be like the maximum value, which is in this case is 2. Like, so this worker is taking the maximum time, so this is 2 into the sum of 1 plus 2 plus 3 plus 4, which is nothing but 2 into uh, 4 into 4 plus, which is 5 divided by 2. So this will be 20. Okay, so there is no way we can exceed the 20 time. Okay, so what we will be doing is that we will be checking, like we'll be doing binary search from one. Like if is there a way in which I can cut down this whole mountain in 1 second, and till till this 20 seconds. Okay, so the answer will lie in this range. So as the answer will lie in from 1 to 20, we can just take a middle point, like somewhere like just say 8. We can check for this 8, like whether I can cut down this mountain this 8. So if I can cut down the whole mountain in 8 seconds, then I'll try like to reduce the time. Okay, so if I can cut down in 8, I'll try to reduce it down. So then next time I will be checking for, let's say, 4. Okay, so whether in 4 units of time I can cut down this whole mountain or not. Okay, so if I'm able to cut down this mountain in 4 seconds, then I'll try to reduce it more, or else I try to see over this side. Okay, if I am not able to cut down this mountain in 4 seconds, then I'll try to see over here, like whether I can cut in somewhere between 5, 6, 7. Okay, so that's how we'll be doing the binary search. Okay, so yeah, let's just see the whole approach with the code, and we will see all the things in the code now. Okay, so let's go to the code. So what I'm doing in the code is that, first of all, I am taking just two like pointers, low and high. So the minimum unit of time which can be taken is 1. Okay, so it's not possible to cut down the mountain in 0 seconds. Okay, that's just not very possible. So the minimum can be 1. Okay, so I'm just taking the -1. And what can be the high? So what can be the most time which can be taken? So the worker which is taking the maximum time. Okay, so the worker which is taking the maximum time, if I assign it the responsibility to cut down the whole mountain height, if I assign the responsibility to cut down the whole mountain height, then whatever the value of it will be, that will be my maximum value. So I will be performing the binary search on that range. So in our example it was 20. Okay, so I will be performing the binary search in that way. So what I'm doing, I'm just I'm doing the binary search, like I'm taking a mid and I'm checking, can workers cut in X time? So can these all workers, like suppose if four workers are given, can these workers work together simultaneously to cut down this mountain in this mid time? Okay, so I'm just passing this to this function call. So if this function call will tell me, like if they can cut it down in, let's say in the mid, like suppose from 1 to 20 it was somewhere 10. So if they can cut it down in 10, so what I'm doing is that I'm marking my answer as 10 for now, and what I'm doing, I'm marking my high as mid minus 1. So as now my range will be from 1 to 9 only. Okay, so I need to check in this range, so I'll be checking in this range. If I'm not able to cut it down in 10 seconds, so there's no point in checking for this part. So I'll be doing binary search from 11 to 20. Okay, so I am increasing my low to mid plus 1 over here as in the else case. So let's see how this function is working. So can workers cut in X time is working like so. What's the maximum cut possible? Okay, so if all of them work simultaneously, if all of them work simultaneously, what's the maximum mountain part they can cut given this time to consume? Okay, if they can take X time to consume, then what's the maximum cut they can make? If that maximum cut possible is greater than equals to mountain height, then I can safely say like these workers can cut down this whole mountains in this time to consume time, in this X time. Okay, so what I'm doing is I'm just going over each worker. Okay, so I'm going over each worker, and for each worker what I'm doing is that I am again performing a binary search. Okay, so by over here I'm doing the binary search. So I need to find out what's the maximum height, what's the maximum height each worker can cut. Okay, what's the maximum height each worker can cut given this time to consume. Okay, given this time to consume. Okay, if worker can cut, suppose uh, what's the maximum cut it can make is will be between zero. Suppose it's not able to make any cut till what's the maximum cut it can make is the mountain height, the whole mountain height. Okay, so the answer will lie in this range. So I'm going over every mid. So suppose if the worker is able to cut for some mid, then I am again what I'm doing is that I'm marking my answer for this worker as like this worker can easily cut down this part for this mid. Then I will be checking for higher values, like because my benefit is when each worker cuts down the maximum part. When each worker cuts down as much part as it can for the mountain, that's when only I will be getting the minimum, right? That's when only I will be getting the minimum for my whole. So I am trying to make as much cut as I can possible, so that my overall time is minimized. Overall time to cut is minimized. Okay, so if suppose this worker can cut this unit of height, then I'll be checking for more unit of height on this side. So I'm taking my low at mid plus 1. Okay, and if not able to cut this unit of height also, then what I'm doing is I'm taking my mid to I'm taking my high to mid minus 1. So I'll be checking in this range only. Okay, so then once I'm done, so for each worker I'm adding what's the max worker cut in that time. So I'll be adding it that in my max cut possible by all the workers. Okay, so so what's this function now doing? It's just checking given this cut for worker. So given this cut of worker and the worker time, like how much time it will take. Okay, so if that time is less than the time allowed, so the time allowed is time to consume. If it can, if it can accommodate this cut, if it can accommodate this cut, then it's valid good. I'll be checking for like higher part. If not, then I'll be checking for the lower part. So that's how this can worker cut in X time is working. So this expression we derived earlier only. This is just the summation of the worker time which we derived for this, right? As you remember, which we derived for this. So once we have checked this, so then I'm just adding it So whatever each worker max cut is, whatever maximum each worker can cut, I'm accommodating it in that, and then I'm just returning if the maximum cut possible is greater than equal to my mountain height. So if I can cut more than or equal to my mountain height, then I am well and good. So I can easily make a cut. So I'll be returning a true in that case. If my maximum cut possible is greater than equals to mountain height. Okay, so that's how the whole approach is working. So now if you are able to see this whole approach, okay, so you can see. So first I'm doing the binary search on answer for time. Then inside this binary search, I'm doing again a binary search. I'm doing again a binary search for the maximum cut a worker can make. Okay, so I'm adding all the workers maximum cut and checking if I can cut down the marketing, if I can cut down the mountain in that time. Okay, so yeah, that's how this approach is working. So I hope I was able to make you understand the logic. Okay, so now let's see what's the time complexity and space complexity. So space complexity will be of one only because we are not using any extra space. We have not used any stack, any array, or nothing. We have used. We have just performed binary search. And what's the time complexity? So time complexity will be O of what? O of first of all, what's the time complexity of this binary search? This will be log of max time taken by single worker into n, because inside this loop I'm iterating n times. So max time taken by highest time consuming worker into n n times the times log of mountain height, because I'm doing a binary search on mountain height, like how much mountain height I can cut given the time. So that will be my time complexity. So this will be something log into n into log. So yeah, so this should fit in our constraints. So if you see the constraints, so the constraints are like this: worker times dot length is 10 to the power 4. So n into log and log, like this should suffice only. This should not exceed 10 to the power 8 in any case whatsoever. So this will be accepted. So yeah, I hope I was able to make you understand the logic. I was able to make you understand the code. So yeah, that's about it. Thank you. It was a really nice question. Hope to see you again soon. Okay.